right, chapter 10, hypothesis testing, the last topic for the semester. 10.1, introduction. 10.2, we're going to hypothesis test for proportions. 10.3, we're going to hypothesis test for means. It's the process, the wording is exactly the same. If you can do one, you can do the other. I'm not going to make you do any math. We're going to use StatCrunch to knock out the results of our hypothesis test. Okay, so I'm going to try and make it as easy as possible in terms of doing the math. The language and the concept is a little confusing at first, and that's why we have 10.1. We're not really doing any testing in 10.1. We're just introducing the topic. Okay, so and then in chapter 11, we get to testing two different proportions or two different means. We're just going to do proportions, and that'll be our last topic. So in chapter 10, we're going to test one proportion. I'll explain what that means shortly. And then in chapter 11, we'll do two proportions. And again, it's very similar. If you can get the basic concept down, we're just going to repeat. One proportion, one mean, two proportions. It's all very similar. Okay, so let's start. In 10.1, we're going to determine null and alternative. I'll explain that in a minute. And then we're just going to do the conclusion. So we're not really doing the test. We're just kind of getting practice with the wording or the language. Okay, so most of you know what hypothesis is. It's a statement regarding characteristics of one or more population. What you think might be true. Right? And then we might want to test that hypothesis. So here's an example. 2008, 62% of Americans regularly volunteered for their time of charity work. A researcher believes this percentage is different today. Okay, so here's the overall idea. I mean, we're not going to get into this into the next section in the next video, but the idea is when for at least the beginning of this, is there's going to be some perceived population proportion, P, in this case 62. And then we're going to do a test. We are going to do some statistics. So we will identify this as P, right? That's the belief. They think that 62% of all Americans, the population is 62%. And then we're going to do some statistics. We won't actually do the sampling. We'll be given some sample statistics, and we'll get something different probably, right? Like let's say we did a test or we sampled 100 people, and we found that 64% of them now volunteer. So the question is this change significant? Did the percentage of Americans really go up? Well, you're looking at it, it went up by 2%, but the idea here is that there is a sampling distribution, right? This guy is right here. The population proportion is right in the middle. The question is, where is this, right? Does it fall, is it far enough away from the center that we can make some kind of conclusion about our hypothesis being 62% of all Americans volunteer? And how do we measure distance from the mean? By standard deviations, right? So this really isn't anything new. The whole idea of hypothesis testing is just really how far away is our sample statistic from our population parameter in terms of standard deviations. That's it. And that's why I've been asking you that question. Is this result unusual? Because it's just a warm-up for hypothesis testing. Okay? All right. So another hypothesis. According to a study published in March 2006, the mean length of phone call on a cellular telephone was 3.25 minutes. So that's mu. Right? We believe the real proportion mean to be 3.25. Okay, so we're going to do this twice. We're going to do it with proportions and means, just like confidence intervals, just like chapter 8 when we did sampling distribution, proportions, and means. Chapter 9, confidence intervals, proportions, means. Chapter 10, hypothesis testing, proportions, means. Okay? So research believes the mean length of the cell call has increased it. Okay, so then we're going to do, eventually, we'll take a sample and we'll get something else, something like that, and then we'll say, okay, did it change? Is it statistically significant? Of course, these numbers are different, but are we far enough away in our sampling distribution, right? This is 3.25. Where does this guy land? If he's like right here, no big deal. We can't say we have enough evidence to suggest that it really changed. But if he's way out here, we're saying, well, wait a minute, something's going on. That's such an unusual observation that we might be able to say something about the real mean here. Okay? That's where we're going. So let's talk about these weird terms. Null hypothesis and alternative. Every single hypothesis test, your first step, I'm going to make you do this. You're going to state your null hypothesis, and you're going to state your alternative hypothesis. So every single one. And for us, it'll either be a P or a mu. Okay? It's always about the population. We're going to use this sample to learn about the population. Okay? So the null hypothesis, denoted H naught, is a statement to be tested. Okay? It's kind of the status quo. What are we testing? Did something change from the null? The alternative hypothesis is what we got from our sample, or what our sample is indicating. Okay, so for example, on that last, let me jump back. This is the null. This is the null. Okay, and this isn't the alternative, but it's giving us some kind of indication to the alternative. Okay, so let me go ahead and do the first one for this example. 62% of Americans. So the null, it always has to be population. So H naught and HA will always be P. It'll never be P hat. Never. Same thing when we do the means. It will never be X bar. It'll always be mu. We're testing something about the population. Okay? So for that first example about the people volunteering, the status quo, or what we believe to be true, is that 62% of Americans are volunteering. Now, the alternative is going to be something that differs from the null. Now, remember, we did a little sampling and got this, but really, you can think about doing the hypotheses before you even do your own statistics. So we just believe it's changed or it's gone up. So we look at the wording. A researcher believes that it is different. It is different. So it is not 0.62. Okay, you're going to have a couple options for that alternative. If it was, we can do greater than, we can do less than, or different from. And that's on my next slide. Okay, every single problem, every single hypothesis test, that is going to be step one. State your null and alternative. Okay, so we're going to have a couple options, like I said. Oh, I just realized this. Your textbook is using null and a 1 instead of an A. I always put an A there for my alternative. It doesn't matter. You can do either one. Equal versus not equal, equal versus less than, equal versus greater than. So your null will always be equal to. Your alternative, you have three options. It can be not equal to, it can be less than, or it can be greater than. Okay? Let's do a couple examples. So, well, first, when we decide, like I said, you're going to get a problem and you're going to say, okay, somewhere they're giving us the null and I have to figure out the alternative. So the null, if you're dealing with proportions, will always be P equals. If we're doing a means problem, the null will always be mu equals. And then based on the problem, you decide what your alternative is. If, for example, that volunteer question said, we think there's more people volunteering, we think there's more people, then we would use greater than. right? And that's what this slide deals with. Not is different from, has changed from, differs from, not equals to, is more than, exceeds, has increased. We use the greater than symbol, okay? And then less than, you've done that in other math classes probably, is below, is smaller than, has decreased. We use low less than, okay? And again, the idea is that right here is what we believe the real proportion or mean to be. It's in the center. And then if our value ends up way out here, we're going to reject the null hypothesis. Okay, so back to my volunteer example. We thought that it was, so change it a little bit. We thought it was the proportion, P is 0.62. Let's say we thought it increased. So our alternative was that more people than 0.62 are volunteering. And we did our sample and we got that 0.64 number. If our 0.64 number ends up out here, if our p hat ends up out here, then we're going to reject the null hypothesis, right? If it's far enough away by standard deviation, if it ends up here, we'll have to decide what our reject value is, how far away we want to be. Think confidence intervals. We built 90, we built 95, we built 99. Same idea with hypothesis testing. How good of a test, how confident do we want to be? But if it does end up in that predetermined region, far enough away, then we're going to reject the null hypothesis. This was the null. We'll reject it. We'll say, oh, that is not true. Right? Because our sample data puts us so far away from what we thought was true, well, we don't think that's true anymore. We're going to reject the null hypothesis, the status quo, what we thought was true. Okay? Okay. All right, so back to those examples. So we kind of already did this. In 2008, 62% of Americans regularly volunteered their time for charity work. A researcher believes this is different. Okay, so here's what you can do for every one of these questions right away. You can do this. H0, HA, colon. Figure out if it's a mean or proportion. This is clearly proportion. P, P. No P hat. Equals. All right, and that right there, what I have on the screen, will be the same for every single proportion hypothesis test. H0, HA, or H1 if you want. And then we'll use P. You'll never use P hat. And the H0 will always be equal. And then you have to decide what symbol to put here. A researcher believes this is different. Is different. Is not equal to. And this is what they think P is. That's going to be step one of our hypothesis test. I'm going to walk you through, when we do these, I'm going to make you do 4 steps. This will always be step 1. Step 2 will determine if conditions are met, which we already talked about, because these are sampling distributions for proportions and means. So we already know what conditions have to be met in order for them to be normal. Right? I was drawing that normal curve. And then we'll use StatCrunch to do the actual test. And then we'll make a conclusion. How about this next one? According to a study published in March, the mean length of a phone call. Okay, here's what you can do. We know that we're dealing with the means. So you can do this every single time. I can do that for every single one of these, right? Because the null is always going to be equal to. And then the alternative, we'll have to decide what sign to use here. The mean length call has increased. That is my hypothesis, my hypotheses, 2 of them, right? The null is always like the status quo, what we believe it to be, and the alternative is what our new idea is. We're going to say, well, I think it increased. Let's see. Same problem, but now we want to talk about the wording. Okay. So when I do, let me insert a slide here. This is where we're going in